and we've gone from drawing a normative conclusion, people are best off when they maximize their utility function, to actually creating a normative valuation mechanism, which is what's their willingness to pay for that thing. That's all normative economics, and it hangs crucially on whether or not people satisfy these critical rationality assumptions, because if they don't, we no longer really know whether maximizing their utility function is actually what's best for them. We do know, we preserve the positive dimension, the predictive dimension, which is if we write down a more psychologically correct utility function, maybe one with a kink in it, we can say that if we then assume that people maximize that kink utility function or that non-rational utility function, we will be able to successfully predict their behavior, but we frequently lose the ability to then say, and that's what will be best for them. So we look at a cab driver and we say, okay, in a very sort of compelling and intuitively right way, these people are leaving money on the table. Okay? If I happen to really, really love tomatoes, and I'm not currently saturated with tomatoes, and there's a tomato on the table, and I'm deciding whether or not I'm standing next to it, and I'm making a decision between should I eat the tomato or not, right? Assuming that my immune system is sufficiently strong to overcome the cooties that this thing now has on it, I should put it in my mouth, right? That's utility maximizing for someone who has monotonically increasing preferences in tomatoes. There was no cost, but I got a tomato. If I didn't pick it up, how are you going to tell me that's normatively correct? How are you going to tell me that if there's a kink in my reference point that makes me not want to eat that tomato, that's somehow utility maximizing in a sense that's normatively meaningful? It was better for me. It must have been better for him to not work those extra hours. It must have been better for him to leave the money on the table. Under standard assumptions, we get to make those kinds of arguments. If a cab driver leaves money on the table, it must have been because they just lost their taste for money. We lose the ability to make those kinds of crisp, stark, normative statements when we abandon these assumptions of rationality. So go through and look at some of those situations. Okay. So, following on that, rationality assumptions. Now, I haven't really focused on this as clearly as I would like to, and I think at the end of this semester I'm going to spend about a half a lecture focusing on this, if time allows. But I have said that there are basically sort of three big rationality assumptions that we're going to, that I don't claim that this is an exhaustive list, but these are the ones we're really going to focus on. Okay, rational preferences, indifference curves don't cross. Complete and transitive preferences. People have a consistent rank ordering that doesn't loop back on itself. So convince yourself that you know what that means, and look at the ways in which violations of that have come up. Right? We saw that the LA paradox violates rationality of preferences. You get a preference reversal. Somebody likes A over B one time and B over A another time. Right? Unless they happen to be indifferent and they're just choosing randomly, which we can usually rule out, it must be that their preferences they don't have this consistent ranking. They have a ranking that loops back on itself. Okay? The next assumption, which we just started to talk about, and we'll talk about a lot more, is rational expectations. That not that people can predict what's going to happen in the future, but that they correctly know all of the probability of all of the different outcomes. That they know what might happen, and they know the probability with which each possible outcome might happen. Okay? That they have a correct knowledge of the distribution of probabilities over possible outcomes. The third one, which we haven't started looking at, and this is my term, I don't know if this is exactly how other people use this term, but this is how I use it, which is rational self-interest. Which basically means that, it means a lot of things. Basically, the way I use it is that it means that people always compute their possible outcomes correctly and really know what the outcome will be of doing A, B, or C, so that then their choices are in some sense rational. So if I'm playing a game of chess, and I just don't know that taking your queen is actually going to cause you to be able to put me into checkmate in 2 moves, I have not maximized my utility, not because I don't have rational preferences over winning, I care a lot about winning, not because I don't have rational expectations, but because I just didn't do the math right. I just didn't get it. So we're going to talk about that later. We've looked at these two, mostly this one. The thing that I want to emphasize about rational expectations at this stage, we're going to talk a lot more about rational expectations over the next few weeks after the exam. The thing I want you to really get at this stage is what happens when your outcomes in different states of the world depend upon the choices you make, either now or then. Okay, so the case that we've seen is if a taxi driver has a reference point that's determined by, has a target, the reference point is this daily income target. If that income target is based on their expectations for future daily income, we know that their daily income is determined by how much they work, by their actions, right? So rational expectations, and you watch economists like a hawk because they'll make some innocuous assumption and then they'll tweak it in a way that makes it seriously non-innocuous. So to say that people have some idea of the distribution of possible wages between Monday and Friday of next week it's a little bit of a stretch, but it's not that unreasonable because these people have been working, but we actually are going to take this a step further. We slip in this extra thing, which is they also have to correctly predict how much they will work in response to those wages. And for their expectations to be rational, they have to be right about all that. They have to not only be right about the distribution of wages, they have to also be right about what their utility maximizing response to those wages will be on those days next week. And then their income target has to be based on a correct understanding of the distribution of wages, which is exogenously determined, and also a correct prediction of how they will respond to those wages, which is endogenously determined by them. Okay? And I drew a nifty little diagram, which I will replicate because I think I didn't really emphasize it as much as I would have liked to. Labor supply. Yeah. No, it was here. Yeah, okay. So what I put on the screen was, if you have an income target, T, that is determined by your expected daily income, W times H star, and if when you actually get into the future and have an actual daily income as opposed to just an expected daily income, you are then going to determine how much to work by solving a maximization problem. Choose H to maximize your utility of labor given your income target. Okay? It better be the case that when you take that T that you determined using your expectations for H and plug it into your utility maximization problem, that you get back out an H, the same H you used to determine that income target in the first place. Okay? Any questions about that? Make sure you understand what those two different concepts of rationality mean and where they show up, how to demonstrate whether or not they are satisfied. Losing my notes. I have lots. Ready to go. Anybody see what I did with my notes? Did they go on the floor? Did I put them? Okay. We talked about reference point determination for not as long as I would have liked. And we talked about 4 different candidates. And then the notes on the handout, I think, should give you as much information as you need about those candidates. One of the candidates was rational expectations, right? So we talked about expectations-based reference points, but implicit in that, or actually explicit if you look at the handout, we're talking about rational expectations. That people's reference point, whether that's a daily income target or some other thing, is based on their rational expectations of what that outcome will be in the future. So if, for example, we're looking at whether or not people will invest in the stock market, we might say that their reference point is based on their status quo income, or we might say that it's based on their rational expectations of what their income would be, conditional on whether or not they invest in the stock market. Okay. We also, what else did we look at? We looked at lagged consumption, which we said is actually a subset of rational expectations, because in many cases, your recent past income or recent past consumption or income or whatever is what you base your future expectations on. Right? I do not anticipate a wage change at the moment, so my expectation for future wage is basically based on what my wage has been in the recent past. We talked about goals and aspirations. Maybe people set some kind of achievement goal for themselves. Maybe this is what that daily income target is. After all, maybe it's an aspirational goal. I will work until I've earned enough money to buy my daughter a new pony. Which is different than rational expectations, because it might actually be the case that you fall short of your daily income target constantly, right? But you keep it high because you really want to push yourself to work. That would be radically different than what we've seen in the taxi driver study. A third one was social comparisons. Maybe what you care about is keeping up with the Joneses, or whether or not you're high or low in the income distribution. So we talked about that a little bit. It explains potentially the Easterlin paradox that as people get more and more, it explains part of the Easterlin paradox. The Easterlin paradox is that an increase in per capita income doesn't seem to increase national average happiness, but big distributions in income within a country do cause big distributions in happiness. And the reason why is possibly because people are comparing their income either to what they had last year or to what other, sort of the median income for their country, and then feeling bad because they're below it or really good because they're above it. We talk a little bit about why reference point determination matters for science, and this is sort of part of the big meta topic of the semester about the scientific process. Psychology and economics, behavioral economics, is rightly criticized for having a sort of scattershot approach to modeling, where we find these anomalies and we say, well, if the model looked like this, it would explain that anomaly. And then sort of walking away like, okay, that's cool, let's leave that here, let's leave it out so people can look at it, and let's go over and do another one. And what we should be doing if we really want to be guilty of doing science is we should stay and we should say, okay, it's not enough to say if we tweaked it in this way, that would explain the anomaly that we just saw. We have to now take this model, tighten it up, and say, what will this model predict that we haven't seen yet? And then we can go and test and see whether that actually happens, right? That's science. That is how you establish theories, is that you come up with a model that explains what you've already seen, derive predictions for things you haven't seen, and go and see if those things actually happen the way your model predicts. Reference point determination is one of many glaring cases in behavioral economics where our models are not complete in the sense that we don't actually have a systematic theory that would tell you, oh, if it's mugs, it's status quo. Oh, if it's the stock market, it's rational expectations. Oh, if it's the labor market on a daily basis, that's income target. We don't have a systematic theory, right? What's the reference point for freeze-dried ice cream among astronauts? We don't have a theory that would tell you that. So if we want to actually be guilty of engaging in the scientific process, we need our models to be complete, and then we need to actually test them to see whether or not their predictions are correct. That's the main reason the reference point matters to me in this class. And there's lots of other cases like that. We saw Bernardsey and Thaler explaining the equity premium puzzle with a model in which people not only have loss aversion, but by the way, they have loss aversion not over consumption, but over hearing about what's happened to their portfolio since the last time they checked. And oh, by the way, they experience that gain-loss utility every time they check. We've taken several steps away from the standard model, and one of the steps we've taken is this question of framing. How do people frame their choices, one at a time or both together, right, or all together? Standard model always assumes that people frame their choices globally. You should make your decision about whether or not to put a cup of coffee on a sloped surface, for example, globally with the risks you're taking in your retirement savings and the risks you take every time you cross the road. But in fact, we don't. We frame each decision narrowly. That's not a complete theory because we don't have a systematic theory for how people narrowly frame things. Alice? So if you're in a class called something or other economics or the economics of something or other, the answer is probably no. Alice's question was, have we studied any models that are complete? Well, you could argue that in problem set 2, when we looked at daily labor supply with income targets based on rational expectations, that was a complete model. Because we told you everything you need to know. Then, everything you need to know to figure out to predict their labor supply is coming from outside the model. If I tell you the wage distribution, if I've assumed that they know what the distribution is, if I've assumed utility maximization using a certain model, if I've assumed that their expectations for their future wage, their labor supply are going to correspond to their actual utility maximizing future, then that's a complete model, and you don't need to make any additional ad hoc assumptions to predict their behavior. Yeah. Okay. Okay, the last thing I want to do, so I want to talk about anomalies. The way I've chosen to teach this class, which is the way that I learned behavioral economics, is through anomalies. Okay? I said on the first day that behavioral economics is a commentary on standard economics. I also believe it's an improvement upon, although I should couch that, I should actually say I believe it can be an improvement upon standard economics, but I'm more confident in saying it's a commentary on standard economics. And the way the commentary proceeds is this. Here's a piece of standard model. It predicts the following. I've observed that the following doesn't actually happen that way. And no matter how hard I tweak the standard model, I can't explain this anomaly. Okay? I can add in this assumption or that assumption, or I can change these parameter values. I can't get the standard model to explain this anomaly, this observed weird thing, which often isn't that weird at all, without violating some rationality assumption. Now I'm going to go over here and I'm going to violate that rationality assumption. I'm going to come up with a behavioral model instead. I'm going to show you that it predicts the thing I actually observed. It explains the anomaly. That's how behavioral economics has actually evolved, so that's how I'm trying to teach it. So one way to sort of structure what you're learning in this course is to sort of go and look at, to sort of categorize things according to anomalies. Right? What anomalies have we studied? What do they tell us about where the standard model fails and what we need to do to fix it? The anomalies that we've looked at so far, I think that this is an exhaustive list, but it may not be. We looked at the difference between willingness to pay and willingness to accept. We looked at indifference curves that intersect. We looked at negative labor supply elasticity on a daily basis, which shouldn't happen. Could happen on a monthly basis or an annual basis. Shouldn't happen on a daily basis. We looked at the rejection of small stakes better than fair bets, right? Would you be willing to a 50% chance to lose 500 or gain 550? We look at the reflection effect. People are risk averse over gains, but risk seeking over losses of exactly the same size. We look at the LA paradox. Okay, to the person who asked me about the LA paradox, no, I don't have time to answer your question. Please come up afterwards and I will. We look at the LA paradox, where if you reframe a choice between gambles in a particular way, you can actually get a preference reversal, where people say that they like A versus B in one case, and then you reframe it and they like B versus A. We looked at people buying lotteries, small stakes, high stakes, low probability lotteries, and also high stakes, low probability insurance at the same time, which we said we can explain with overweighting small probabilities and certainty, not certainty effect. And we looked at the equity premium puzzle, right? The fact that people have to be paid a monumental amount to buy stocks at all versus bonds. I say I've got a minute and 12 seconds, and I'm going to take them, so don't put yourself away quite yet. We have looked at, roughly speaking, two ways of sort of demonstrating that something's an anomaly. Right? The way that this field of economics proceeds is that we see something that seems like a puzzle, and we then need to actually convince ourselves and convince, hopefully, standard economists that it is in fact genuinely a puzzle, that it's really an anomaly that really can't be explained by the standard model. One of the ways that we've done this over and over again is by using what I refer to as an implausibility argument. Okay? No matter how hard I tweak and massage the standard model, in order for the standard model to explain what I see in the data, or to explain phenomena that I know actually happen, I would have to set the parameters of this model to an implausible level. Right? So I would need risk aversion 30 times as strong as what we actually observe in the real world. Or, it's implausible that people reject small stakes bets because over any range, if they reject these small stakes bets, then they would also reject these insanely huge bets that we just know people don't reject. These are implausibility arguments, and we've made a number of them. The other way that we try to show that something is an anomaly is by actually coming up with a crisp prediction of the model that says, under the standard model, this should be negative, under our model, it should be positive, or 0 versus positive, and actually going and testing those predictions rigorously, usually in an experimental setting. That's a completely different approach than the implausibility argument, so make sure you understand the difference between those two approaches. Okay, I'm done. See you on Thursday.